Hello guys, welcome to the daily lead code challenge problem maximum number of fish in a grid. In this problem, we are given a zero index 2D grid. Grid is a matrix which is of size m cross n. It is not a square matrix because the rows m is different from n column. It could be square but it need not be. Okay, and then it is mentioned that a land cell is the grid cell is land cell if it is equal to 0. It is water cell if it is not equal to 0. And the water cell not equal to 0 value will be denoting the number of fishes that cell has. Okay, so what we can do, the problem is that we want to catch the maximum number of fish. Okay, but what we are restricted with, that we can catch the fish in a cell and move to any adjacent cell. So we, to move to any adjacent cell, we can go to the next column, go to the previous column, go to the next row, go to the previous row. So only these four movements are allowed. Okay, so how to solve this problem? So see the visual diagram here. See here, if you are starting from this grid, then we can come down, but since this is a land cell, we cannot go here. This is a land cell, we cannot go here. Diagonal movement is not allowed. We cannot go to next row and next column. Okay, only we can go to the next column, same row, uh, uh, previous row, next row, and then previous column, same row. So only four movements are allowed. So if you are in this, then we can only go down and only five fishes we can catch. If we are starting in any of these two rows, then we can catch three fishes. If we are starting from any of these two, then we can only catch five fishes. But we start any one of these two rows, these two cells, then we can catch seven fishes, and that's why the answer is 7. So this is one component, this is one component, and this is the another component, and this is the another component. So this component is giving the maximum return, and that's what we have to tell. So in order to solve this problem, what we can do, that we can uh, use this as a grid. I'm going to say use this as a graph. Okay, 0 dot length, and then private int fish is equal to 0, and then boolean. Okay, boolean, no, boolean is not required. So what we will do, we will go through this. For int I is equal to 0, I less than n is the number of rows, and then we will go through the like this. If grid of ij is not a land cell, so if it is not equal to 0, then we will start a DFS on the grid I j. Okay, and then we will collect some fishes. So we will do, so here we'll declare one more variable, int max fish is equal to 0, math.max of max fish. Okay, and this we will store in the max fish variable. Okay, and then we will return this. Okay, after doing this, what we will do, that we will do private void dfs. Okay, and in this we will pass the grid, and then we will pass the row and int column. So if grid of row and column is equal to 0, then we'll just return. Otherwise what we will do, that we will do this dot fish plus is equal to grid of row and column. Okay, and then after doing this we will set the value back to 0. Why we are doing it? So that, you know, since we have collected all the fishes, no sense going back to it, so we'll set the value to be 0. And then dfs of grid just the grid row minus 1 call. So we can go back to the row minus 1. How? If we can go back to the row minus 1 if row minus 1 is greater than equal to 0. Okay, if row plus 1 is less than grid dot length, then we can go to the row plus 1 as well. So row plus 1 column, and then the other is if col minus 1 is less than grid row is 0, 0 less than minus 1 is greater than equal to 0. Okay, then also we can do grid row col minus 1 if col plus 1 is less than grid of row dot length grid row 1, like this. So if you are able to do this, so what we are doing here, see, basically this problem is about connected components. So this is one component, this two cells is one component, these two cells is one component, these two cells is one component, and these two cells is one component. And as a basic property of DFS, that if we traverse a graph, then DFS, you know, finds the connected component from the starting vertex. So this is the basic property of, you know, DFS which we are utilizing here. So DFS finds the connected components of the starting vertex. Okay, if you are able to find this, you know, so for that only we are using this DFS, and then after doing this DFS we are, you know, saving the number of fishes obtained, and before this we need to, you know, this dot fish is equal to 0, because every connected component traversal is going to give some fish value, and we want it to be starting from 0 for every connected component, and then we'll be getting the maximum after the traversal and storing it in the max fish variable, and whatever is the maximum we'll be returning it after the function is completing. So let's just run this. Perfect. Perfect. So I hope you liked this. With this, I'm thanking you. Thanks a lot. Happy coding. Best wishes.